Now that we understand how to work with variables that are in more than two variables, we've got the third variable called z. We're going to discuss how to take derivatives. The important thing you need to understand is which variable is going to be treated as the variable, and all the other variables are going to be treated as constants. So let's start out by reading what's in the notes. In order to differentiate functions that contain more than one independent variable, use the process of partial derivatives. In this process, differentiate with respect to one variable at a time, while the others remain constant. So you'll see what I'm talking about. We need to understand the notation because it's going to look a little bit different for partial differentiation. So we have a function z that's in terms of x and y. That's your function called f. The partial derivative of f with respect to x is denoted by this little funky symbol here, also known as this notation over here. So the notation, this is your partial differentiation symbol of the variable z, that's your function's name, with respect to x, means that all other variables besides x are treated as constants. The variable y, therefore, would be treated as a constant, right? Because your function is in terms of x and y. So the variable that's in the bottom of your differential expression tells you which is the variable, and that means that everything else is a constant and is treated as such when you take derivatives. This gives the rate at which the function is changing as x changes, but y is held constant. So your variable y is a constant and x is allowed to change. And you're going to see how that applies when we get into marginal analysis. All right, the next idea is going to take the partial derivative of f with respect to y. This time y is your variable, and in that case, x is treated as a constant. All right, the other notation you're going to see, and I'll try to mix and match here, is f with a subscript of y. That means that y is your variable. Y is your variable. Everything else is a constant. Now this is going to give you the rate of change of the function as y changes, but x is held constant. So you're not changing both at the same time. You're not changing the values of x and y at the same time. You change one at a time, leave the other alone, see what the result is, and then go back and change the opposite variable. So let's see how to take some partial derivatives. So you have a function f for number one, given in terms of x and y. The first thing that you're asked for is the partial derivative of f with respect to x, which means x is your variable. I could have written this as partial of f with respect to x. That notation works as well. So be familiar with both based on the problem that's given you. It could mix and match the types of notations. This means that y is going to be treated as a constant, okay? Y is treated as a constant. So let me highlight the y variables so that we understand that we're going to leave these as constants. When we take derivatives, we're going to use that appropriately. So when we take the derivative with respect to x of 3x squared, x is a variable. We treat it just as we always would. That's going to give you 6x. Now the next term, when we take that derivative, remember that y is a constant, and obviously 10 is a constant, right? So the only variable is x. So we're going to take the derivative of negative 10xy, and we're going to get negative 10 times y. Right? Y is a constant. Treat it just like you would any other number. When you have a number like negative 10 times x times y, which is also a number, and you take the derivative, that's going to give you negative 10y. Y is a number or a constant. Next term is 2x. We're taking the derivative with respect to x, which means we get 2, just like normal. The next term is 4y cubed. Now, y is a constant, isn't it? So 4y cubed is just another constant. And the derivative of a constant is 0. And finally, we have plus 5. That's obviously a constant. Its derivative is also 0. So this first part is done. That's the derivative of f with respect to x. The next part wants you to differentiate f with respect to y this time. Now, y is your variable. So this could be written as the partial of f with respect to y. Okay, so I'm going to get rid of my notation from up here so I can re-highlight the constants this time. So this time the x variable is a constant. So this is a constant, 10x is a constant, 2x is a constant, 4 is a constant, and 5 is a constant, as you might have assumed. So differentiation with respect to y. The derivative of the first term is 0, because it's all constants. The derivative of the second term, remember x is a constant, with respect to y is going to give you negative 10x. The derivative of 2x, that's 0, because it's all a constant. The derivative of 4y cubed, y is your variable, so we get 12y squared. The derivative of plus 5, that's a constant, you get 0 from that. So that takes care of that example. All right, so number 2 is a little bit more involved. It's got a lot more things going on. So we have to remember how to handle the power rule and the chain rule and how to differentiate natural logs all on the same problem. So let's first understand how to find the derivative of this function called p with respect to x. In that case, y is your constant. Y is your constant. Y is your constant, okay? So when we take the derivative, we bring the 1/2 down in front. We repeat everything inside the parentheses, just as it appeared. Don't change a thing. We subtract 1 from the power. And now we use chain rule, right? Take the derivative of what's inside the parentheses. Let's underline that for you. So derivative of what's inside the parentheses. Don't forget which one's the variable, which one's the constant. Here's the constant once again. All right, so the derivative is going to be negative 12x squared, and that's it, because the derivative of the entire constant, 8y squared, is going to be 0. The next term, underline it for you, is 4 natural log of xy. Derivative of a natural log is where you take 1 divided by whatever you had the log of. Don't change a thing. But now multiply by the derivative of what the bottom part says. Don't forget y is your constant. And so the derivative of xy with respect to x, so y is your constant, is y. The next term is 15x squared y cubed. Don't forget y is your constant. So the derivative is going to be 2 times 15. Let's write that out. 15 times 2, right? Bring the exponent down in front, times x to the first, times y cubed, because isn't y cubed just another number? So it gets multiplied all along, just like that 15 did. The last term right here, negative 25xy, taking the derivative, y is your constant. Say that to yourself as much as you need to. Now that we're not in the classroom, when we're taking tests, you can talk to yourselves. Nobody's going to think you're weird, and you're not going to disrupt anybody. So, negative 25xy, the only variable is the x, right there. So the derivative of negative 25xy is negative 25 times y, right? And then you can simplify that a little bit. It doesn't have a whole lot to do. I would probably cross out those common factors of y. I would multiply 1/2 times negative 12. I would call that negative 6. I would call this 30. And that's pretty much it. So don't waste a lot of time simplifying. I'm not even going to write that out. Computer should take your answer without being simplified. That's just more things to type in. All right, now we're taking the derivative of the function p with respect to y. So let me get rid of everything I highlighted up here. And let's do it again. This time my variable is y, which means x. X is my constant. X is my constant, okay? So x is my constant. Here we go. So the derivative of the first term starts the same way. We bring the 1/2 down in front. We get negative 4x cubed plus 8y squared, because you don't change anything, to the negative 1/2 exponent. Next is the chain rule. The chain rule says that you want to take the derivative of what is inside the parentheses, which is here. Okay, so I'm taking the derivative of the part that I just underlined in green. So the derivative, don't forget what your variable is and what your constant is. X is the constant and y is the variable. So here we go. The derivative of negative 4x cubed, well, that's just a big constant, so that's 0. And then the derivative of 8y squared is going to be 16y. Take Takes care of that. The next term that I'm differentiating is this 4 ln of xy, and I seem to have erased my highlighted the x. Okay, so the derivative of 4 ln xy is going to be 4 times 1 over xy times the derivative of the denominator. Don't forget, there's your constant. So the derivative of xy, with x being the constant, is just x. The next term is your 15x squared y cubed. The derivative, don't forget what the constant is right there. The derivative is going to be 15 times, bring that 3 down in front, from the y cubed, bring that 3 down in front. The x squared, that's just another number, so put it next. And then y gets raised to the second power because that's 3 minus 1. Finally, I have the derivative of negative 25 xy. I highlighted x because that is the constant, and you end up getting negative 25 times x. And simplify a little bit if you'd like. I might suggest canceling out these like factors right there, the x's. You could multiply the 1/2 and the 16, call it 8. You could multiply 15 times 3, that's 45, and that's pretty much it. Example number 3. So now we're going to find the derivative of this function g with respect to x. So your y is your constant. Let's highlight the constants. Highlight the constant. That's your constant. So notice that I have an x that's in the x squared part of the function as one factor, and then I have an x in the e to the 2x factor, and that third factor overall. And so I have to use the product rule. Because I have x's in both places. Okay, so where does that y cubed go? Should it go with the first part or should it go with the second part? And the answer is, doesn't matter. So I'm going to put it with the first part. That's my first part. Here we go. This is my first part, and this is my second part. Okay, so when I take the derivative, I am going to use product rule. So the product rule says, find the first part, don't change it, just repeat it, times the derivative of the second part. So the derivative of e to the 2x is 2 times e to the 2x, plus the second part, which is the red, e to the 2x, times the derivative of the first part. The first part was underlined in blue. Y is your constant, treat it as such. So the derivative of x squared times a constant is going to be 2x, bring that x down in front, times your constant. That's still there. Don't change it. You can simplify this a little bit. We'll go ahead and do that. Anything that's the same, we're going to bring that out into the front. Before we do that, let me give you one step. Let's get this 2x squared y cubed e to the 2x plus 2x y cubed e to the 2x, just so it looks a little bit more concise. Now I'm going to factor out the common factors that appear in the first part as well as the second part. Okay, so bring out the common factors. You're going to get a factor of 2, an x, how about a y cubed, and that e. All of that is redundant. It's in both parts. So now what's left? Well, let's see. The 2's gone. The x, I have one of those x's left. Everything else got wiped out. From the second term, I have nothing. Everything got brought out. So I need to put a 1 as a factor in that spot. So that is your simplified answer right there. That's where you should get to. However, Connect Math should have taken what you got there. That would be okay for Connect Math, but this is better. And it will especially be better when you get to a little bit further when we use that to do more with it, okay? So I'll get into the habit of simplifying all the way down if you can. The next example is going to take the derivative now of g with respect to y. So in this case, our constant is your x. So let's highlight the x and the x. All of that is constant land. And the only variable I've got is y cubed. And that is the only place that y appears. I don't need to worry about product rule in this case. Don't need product rule for this part because I can find the derivative without. I only have one location where that y appears. Everything else around it is constants. So if you want to, here, check this out. You can write all of those constants up front together and then the y cubed later if you want, because then when you take the derivative, you know to take the derivative, pretend like all of this is pretend like all of this is a constant, right? So when you take the derivative of a number times y cubed, what do you get? Well, you bring that 3 down in front, and you multiply by everything else that was in front of it already, all that constant, and then y gets raised to the second power because it's 1 less. That's it. Don't need those parentheses. So rearrange that function if you want to. Since everything's multiplied together in the beginning, it doesn't matter the order that you choose to multiply. You can flip things around, put all the constants together, put the variable later if you want to, and then when you take the derivative, it might be easier for you to see how to do that. All right, I think I can squeeze one more example into this video, so let's do number 4. The function is the natural log of a quantity. Just think of it as a quantity. The first part says take the derivative with respect to x. So let me write out what this means with partial notation. The partial notation would say this is the partial of f with respect to x. Okay, so your variable is x, and that means that y is your constant. Y is your constant. Okay, so if I take the derivative of the natural log of an expression, I get 1 divided by the expression times the derivative of what's on the bottom, right? Well, don't forget, that's a constant. So when you take the derivative of x squared plus a constant, what do you get? Just 2x. So that's pretty much it. I would write that as 2x divided by x squared plus y cubed. Done. All right, the next one says take the derivative now with respect to y. So with partial notation, this would be the partial of f with respect to y. And so that means that your variable x is no longer a variable, it's a constant. X is a constant right there. Okay, so the derivative of the natural log of an expression is 1 over the expression. We learned that before spring break. And then take the derivative of what's on the bottom. Don't forget, that's a constant. Okay, so the derivative is just going to be, what, 3y squared, because the derivative of the constant is 0. So I would write that as 3y squared over x squared plus y cubed. And that one's done. So let's stop there before I continue with the examples with regards to applications.